Alright, happy Sunday. Last time I did a SL paper 1, and I'm going to do the other SL paper 1 from May 2018. This one is time zone 2. Mostly because this week has been actually pretty busy for me, so I'm not really in the mood for doing anything crazier than like a calculator or a non-calculator SL paper speed run probably. Oh, hello Ashley. And we'll see. It's good. How are you? How's your break so far? Okay. But I am planning on finishing this up soon. So last time I did, I skipped a bunch of questions. And I feel kind of bad. So even if it's not part of the curriculum, I'm going to do this again. 7 assignments. Nice. If you do one every day, then you'll finish before the break is over. Okay, so as a warning, this is now HL content, vectors. So we have O to A is 213, A to B is 131, and then there's going to be a line that passes through A and B, and then find the vector equation for the line. So this line, it needs a position vector. Can you tell me an easy way to factor trinomials? Not really, you just gotta practice. And then you add some multiple of the direction vector. And depends on, you know, your style, but this multiple, you can call it lambda. Or T or S or whatever. Okay, so because this line is from A to B, OA is actually the position vector of A. And then AB is our direction vector because we want a line that goes from through A and B. So in other words, I don't know what video you're watching, but there's lots of ways to do factoring. So I can't really tell you which way, you know, your teacher wants you to do it, if there even is a particular way. Okay, so here's my equation for line 1. Just keep watching videos until you find one style that you like. Okay, what's next? So this vector is perpendicular to A and B. Find the value of P. So that means that if I take 2P0, right? And I take the scalar product with the direction vector of AB, since they're perpendicular, that means that the angle between them is 90 degrees. So if we go to your formula booklet on the dot product, scalar product, you see, you can define the dot product as the length of the first vector times the length of the second times cosine of the angle between them. So if they're perpendicular, the angle is 90 degrees, or pi over 2. So cosine pi over 2 is 0. So the dot product, scalar product of any two perpendicular vectors is 0. And then, in other words, 2 plus 3p needs to be equal to 0. This is the other definition of dot product, where you multiply each corresponding components together and then you add them up. And then from here, it's pretty straightforward to find out what P is. Negative 2 over 3. Okay, but enough of that. Let's do a proper SL question. Hello, squishing. So here we have a parabola with this formula. And then we need to find the integral. So a little calculus question. So we can split this integral into separate terms. And each one of these is easy to figure out. Okay, and then we add a constant because we don't really know much about this integral. And then it says here that the area enclosed by the region between the graph, the x-axis, and then the lines from x equals 1 to x equals 2, they're just saying find this area. So that's easy enough to do. All that is this is just the integral from 1 to 2. Of this thing, part A. Two positives make a negative. They do. Hello, OG Ponda Master. But we already figured out what this is in part A. So we just find the definite integral. Easy peasy. So what do we have? 2 times 2 to the power of 3 minus 3 over 2 times 2 to the power of 2 minus 2 plus 3 over 2. Okay, this is 16. This is 6. So 16 minus 6 is 10, minus 2 is 8. 8 plus 3 over 2 is 19 over 2. So that should be this area right here. Nice, going along smoothly. Aha. Something my students can finally know what's going on. So if I have a set of data and there's a certain amount of data points. And then I know if I add up all of the data, it's gonna be 800. And I know the mean is 20, so how can I find out how many data points there are? Well, this is easy enough, right? Because the definition of a mean is if you take the sum of all your data and you divide by how many data points you have, well, you should get the mean. So that needs to be 20. In other words, n has to be, what, 40? Okay. Next up, The standard deviation of this data set is 3, sure. And then for some reason, we multiply each value by 10. So what's the new mean going to be? We just take the old mean, and then we multiply by 10 as well. So it's the new mean is going to be 400. Okay. And then find the value of the new variance. So what I prefer to do is I find the new standard deviation, which is just 10 times the old one. So that's 30. And then the new variance is just the square of the new standard deviation, which I just found out is 30. So 30 squared is 900. Okay, what's next? We got this diagram with a circle, radius, and angle. And then the points A and B are on the circumference, okay, blah blah blah. The area is 12 and the length is 6. So the length is 6. And the area is 12. And then I probably want to find, oh, okay, the value of r. So we have two variables. We have two sets of informations, the arc length and the area. This basically creates a system where we can solve for r. So the arc length formula is just theta times r. And then the sector area formula is 1/2 I think theta r squared. Okay, now we know what each of these things are. This is 6 is theta times r, and the area is 12, so this is 1/2 theta times r squared. Now since I want to solve for r, what I'm going to do is I'm just going to isolate for theta. So theta is 6 over r. So that when I make a substitution into the second equation, the only variable I have is r. So now this becomes 12 1/2 6 r. Oops, that should be over r. Times r squared. So we have 12, and then the 1/2 times the 6 is 3, and then this r down here is going to cancel out with one of these r's. So you get this equation. In other words, r has to be 4 centimeters. Nice, easy peasy. Ooh, function stuff. Hey RGPT, how's it going? Are you busy as always? Ooh, took it easy, nice. How long has it been since you had a relaxing Saturday? Or Sunday? Nice. Yeah. So after Thursday's stream, holy moly, 2 to 3 months. I realized I didn't finish all the readings, so I didn't actually get to start my homework until the day afterwards. But I finished that homework pretty quickly. It was honestly not as hard as I thought it was. But even though it's spring break and I have my 2 weeks off, this last week I've just been cleaning up my house, packing everything away because we're gonna sell it soon. So we gotta make it look a little bit nice for people that come and check it out. So it hasn't been relaxing at all so far. Okay, what is this? We got a function. Looks like that. And then now we need to sketch this function. So we just need to identify what kind of transformation that is. And this is a reflection. Across the y-axis. So all we can do is just make sure that this is reflected properly. I feel like I might have given this I might have given this to my students on their last test. But looks something like that. Okay. And then we have a different function g, and g is just more transformations of our original f here. So you can see that it has two transformations applied to it. Some sort of vertical stretch and possibly reflection. And inside the actual function notation itself, parameters, we have a horizontal translation. So here is the two transformations applied to f, which creates this g. And then we just need to find out what a and b are. Okay. So comparing the two. Obviously this is upside down. So I know a has to be a negative value. Now, does it stretch it? So if you look at it, right here, right, this gets flipped upside down. And then it should look like it should look like this. And then as you can see, it kind of gets pulled downwards and it gets vertically stretched. This is a little weird. But okay, let's go over this. So you can see that right now, this has a vertical height of 2 squares. And then if you compare that to this graph, this has a vertical height of 4 squares. So it's clearly been vertically stretched by a factor of 2. So a is negative 2. Now b is the translation. So if I were to stretch this out by a factor of 2, then it should look like this blue graph right here, right now. But it's a little bit off. Because if you notice, this is from negative 4 to 2, whereas this one is from negative 3 to positive 3. So it has shifted horizontally to the right. So before we decide what b is, this goes to the right 1 unit. Now, normally what that means is that you would write this as f of x minus 1. And then typically, well, not typically, but the general formatting is you write it in general format with a subtraction. But if you notice the question, they're a little bit mean, and they say it's plus. In other words, b is actually -1. Because we actually want to have an x minus 1, but then the general formatting in the question is plus b. So b has to be a negative then. That's kind of stupid, but something to be a little careful about. Okay. Making good time. Okay, what do we have? We have a polynomial, well, a quadratic, and then you need to find the number of roots. So we're not actually trying to find out what the roots are themselves, we're just finding out how many there are. So we check the discriminant. Because that will tell us. So what do we got? We have, this is A, this is B, this is C. So the discriminant is b squared, which is q squared, minus 4 times A times C. So here's my discriminant. Now, the discriminant has 3 options. It can be positive, it can be equal to 0, or it can be negative, less than 0. So if it's positive, then this has 2 real solutions, 2 distinct real solutions. So this is like, if you were to graph this parabola, it has 2 x-intercepts. If it's equal to 0, then it has 1 distinct real solution. So if you were to graph it, it only touches the x-axis once. In other words, the vertex is the solution. And the last one, no real solutions. So if you were to graph it, we graph a parabola that does not intersect or touch the x-axis. Okay, so how can we determine whether this is positive, negative, or 0? I have no idea what p and q are. Well, at least I know that p is not 0. Q could be 0 for all I care. But let's take a look at this formatting. This is a variable squared. Something has been squared. This will always be positive. It doesn't matter what p is, it will be positive because you square it. Or q, sorry. Likewise, p, same thing. And because we're also adding, and we're multiplying by 16, that doesn't really do much. But this is always going to be positive, regardless of what p and q are. I can't change my color. So according to our, our talk about the discriminant, because it's positive, I will have two distinct real solutions. Moving on, looks like we have a sequence and series question. So we have this arithmetic sequence. So we have U1 is log CP, U2 is log CPQ, and then C and P and Q or whatever. So show that the difference is this. So there's lots of ways to do this. But traditionally, if we had two consecutive terms in a sequence, arithmetic sequence, if we just subtract them, we should get the difference. So using our actual values of U2 and U1, okay, now from here, there's lots of ways that we can show that this is going to be D. You can use log rules to combine these together. You can use log rules to split these apart. It doesn't really matter, it's up to you. So I'm going to split them apart. And then these log p's will cancel out, and then you're just left with what you wanted to show. So easy peasy. Okay, now p is going to be c squared and q is going to be c to the power 3, and then we're going to find the arithmetic sum from the first term to the 20th term. So first off, because we know what p and q are, let's simplify u1. Since u1 is log cp and p is c squared, this just becomes 2. And we also need the difference. And for very similar reasons, d is 3. So now we can find our sum. This is just, standard formula book calculations. So that's 10, this is 4, and then 19 times 3 is what, 57? 61 times 10. So 610. Excellent. Now I've reached the longer questions. How many are there? I think there's just 3, right? Okay. I feel like I've done this question already. Oh well, let's do it again. Pablo drives to work. The probability that he leaves home before 7 is 3 out of 4. And if he does leave home before 7, then the probability he's going to be late for work is 1 out of 8. But if he leaves home at 7 or later than 7, then his chances of being late for work increases. So now we fill out this tree diagram. Okay, so it says here 3 out of 4 is his chance to leave before 7, which means that 1 out of 4 is his chance to leave after 7 or at 7. And then we need to fill out this. It says here that if he leaves home before 7, then the chances of him being late for work is 1 out of 8. So this part of the tree is 1 out of 8, which means that this tree is 7 out of 8. Okay, next. Find the probability that Pablo leaves home before 7 and he's late for work. So he leaves home before 7, so we're taking this branch, and he's still late. So to calculate this probability, we just multiply the two separate events together. So him leaving before 7 with him being late anyways, which is 3 out of 32. Okay, next up, we need to find the probability that Pablo is late for work, period. So we found out one option for him being late. However, there is a second option, and that's if he were to leave at 7 or later, and then he still ends up being late. So this probability, it's the same as the one we just did. We multiply the two events together. So 1 out of 4 times 5 over 8, which is 20 over 32. So these are the only ways that he can be late. So the probability that he is late is we add the two separate probabilities together. So 3 out of 32 plus 20 out of 32 is 23 out of 32. Okay. Then we're asked this question. Given that he's late for work, find the probability that he leaves before 7. So this is a conditional probability. There is a pretty standard formula for it. Following the formula, we take the probability that he left before 7 and still ends up being late, and we divide by the probability of him being late overall. And those are what we found out in both part B and part C. So this is leaving before 7 and being late, and then this is just being late. In other words, this is 3 over 32 over 23 over 32, which essentially simplifies to 3 over 23. Then, the next 2 weeks, Pablo's going to drive to work, and then find the probability that he will be late at least once. So for him to be late at least once means that he's either late both times, so late and late, or he's not late and then he's late, or he's late and then he's not late. So we calculate the probability of each one of these and then we add them up to find out this probability here. So this was what, 23 out of 32? And then for each day, we multiply by each probability of being late. Him being not late is the complement to 23 out of 32, which is 9. And then him being late and then not late, it's the same probability. So what I can do is I can just add 2 of this together with him being late twice. And then they want you to calculate this without a calculator? But why? Why would they do this to you? Alright, well they don't want a calculator, so I guess I gotta find out what 32 times 32 is. So I gotta do this the old-fashioned way. $1,024, and then I need to calculate 23 times 23. Oh, actually, let me show you a cool way that works for small numbers. Japanese multiplication. So I think it goes like this. You draw... So you draw 2 lines and then 3 lines. So this represents 23. And then your other number, your other 2-digit number, you draw on the other diagonal. So like that. And then essentially, if you look and you count the intersections, this will tell you the results of the multiplication. So over here, you have 3 by 3, so then that's 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here, you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is 12. And then this one is 1, 2, 3, 4. And then essentially, because this is place values, we have to carry the 1 over here. So the answer is 529. So that's 23 times 23. I don't know if this is faster than doing it this way, but oh well. Okay, and then last one is 2 times 9, which is 18. And then 18 times 23. Actually, I think that's less efficient than me doing 9 times 23 is essentially 230, which is, 23 times 10. And then because we actually don't have 10, we have 9. I'm going to subtract one amount of 23. So this becomes 227. And then I'm going to multiply that by 2. So this becomes 454, I think. Okay, so what does this all mean? That means that this probability is 1024. So 529 out of 1024, and then I'm adding out of 1024, 454. I don't know why they're making you calculate this. So what do we got? We got 3, 8, 9. So this should be the probability that he's late at least once. Now, there is a shorter way to do this one. And that's probably the way that they wanted you to do it, to be honest. But if you need him to be late at least once, then there's only one option that he's not allowed to be, and that's being on time both times, right? So the probability of being late at least once in other words, this is the probability of not being on time both days. And this is probably easier to calculate because we just take 1, which is the total probability of everything, and then we take away the probability of him being on time both days. And him being on time both days is 9 out of, I think, 32. And then you have to square it, 1 for each day. And you still have to do some work, but I'm assuming that you'll get this. You should get the same answer. 3, 9, 4? Oh, should be 8. I messed up somewhere. Time to cheat. So what's 32 times 32? Okay, that's correct. Okay, what's 23 times 23? 529, okay. That looks good. And then what's 9 times 23 times 2? Oh, 414. How did I mess that up? So this should just be 414, which changes this to the correct answer. How did I mess this up? What's... Nine times 23 is 207. Oh, I can't subtract. So 207, 207, 414. My bad. Okay, either way, you'll get this answer. I've done this question too before. So we have a cylinder, radius, height, volume of 20 pi. And then we need to express h in terms of the radius. Okay. So the volume of a cylinder is pi r squared times h. And if we know that the volume is 20 pi, then we can just, isolate h. So h is going to be 20 over r squared when you divide through to the other side. Okay, Material of base and top costs 10 cents. Material for the curved side costs 8 cents. And then we need to show that this is the total cost. Okay. So the cost is, right, 10 cents times 2 of the areas of the circles, which is just pi r squared, plus 8 cents for the area of the wall, the curved part right here. So the curved part is essentially a rectangle. So if we were to, like, imagine you just cut this down like a toilet roll, like the cardboard thing that your toilet is wrapped around. You cut it through the middle, and then if you unwrap it, it makes a rectangle with a height of h, the same height as the cylinder, which is 20r/2. And then the length of this rectangle is the circumference of the circle, which is 2 pi r. So the area of this thing is, well, 2 pi r times 20/r², which is 40 pi over r. And then if you multiply this out, you'll get this. Okay, next up, we know there's a minimum value for c, so find this in terms of pi. This is an optimization question, so we're going to find out what c prime is first. So we take the derivative, pretty standard stuff. And then I want to set this equal to 0 because I'm optimizing. And I'm going to solve this equation here. Before we do, I'm going to multiply everything by r squared. And then you'll have this, and then this is way easier to solve for r. So what happens now? R cubed is going to be 320 pi over 40 pi. And then pi's cancel. 32 divided by 4 is 8. Which means that the radius is 2 for our optimized thing. Okay, this is just the radius of that gives you the minimum cost, and they want you to find the minimum cost itself, which means that I plug in 2 for my radius into the cost formula. So 20 times pi times 2 squared plus 320 pi over 2. So that first term, 2 squared is 4, 4 times 20 is 80 pi, and then likewise 320 divided by 2 is 160 pi, and then 80 plus 160 is 240. So the cost is 240 pi dollars or cents. Okay, and then I think I'm on the last one. And honestly, Sundays are a little slow sometimes. Today's a slow Sunday. So I'm just gonna check my answers, and then I'm gonna call it a very quick stream. Okay, we have a function, f, and then we have a line, and then the line, I've done this question too, what the heck? Oh well. And then this is the equation of the line, and this line is the tangent line to the graph of f at x equals 2. Okay, find the derivative of f at 2. So this is the tangent slope, or tangent gradient. And since we have the equation of the tangent line, it's very easy to find out what the gradient is. It's 3. Sad, don't be sad. And then the value of f at 2, it should be the same y value as the line at the x value 2. So what I can do is I can just plug in 2 into the line equation, which is 7. Okay, and next up we have g, and then g is f of x squared plus 1, and then p be the point on the graph of g, and then this is where it's 1, sure, whatever. And then 52, yeah, I know, streaming for 52 minutes. Okay, show that the graph has a gradient of 6 at p. Okay, so we want to first find the derivative of g. So according to that, it is the derivative of f at x squared plus 1 multiplied by 2x. This is just the chain rule. So I take the derivative of f, and then I take the derivative of the inside parameter of f, which is x squared plus 1, and multiply them together. And I want to find the gradient of this at the point P, which has an x value of 1. So this is g prime at 1. So you plug in 1, you'll get f prime at 2 multiplied by 2. F prime at 2, they told us, or we found out, it's 3. So this is just 3 times 2, which is 6, so we know that that's correct because they actually told us already what it should be. Okay, next up. Line 2 is the tangent to the graph of g at P. And then L1 is going to intersect L2 at a third point Q. And then we need to find the y coordinate of Q. So L1 which was this equation, is going to intersect L2. Now first we need to find the equation of L2. I did just find out that the tangent gradient is 6. And then I need to find out the full equation of the line. So I'm going to use point gradient form because I can find out a point on G. So I know that if my x value is 1, then G of 1 is the same as f at 2, which I found out in part A is a y value of 7. In other words, point P has the full coordinates 1 and 7. So putting this into this formula over here, this is the equation for line 2. Okay, and then I need to find the y coordinate of Q. So there's lots of ways that we can do this, because essentially we have a system. But since I want to find out what y is, I'm going to just eliminate x. So I'm going to multiply this by 2. So that when I do a subtraction, let's do this one minus that one. Then I'll have positive y, and then 6x, so 2y minus y is y, 6x minus 6x is 0. They've been eliminated. That's the whole point of multiplying this whole equation by 2. And then 2 minus 1 is 1. So there you go. And then I am done this paper. And I didn't even skip any questions. Alright, and that is at 56 minutes. Not bad, considering you're allowed an hour and 30 on this. And I was going at a pretty chill pace. So let's see how I did. Okay, let's see. 213, 131. And then I have the same thing right here. P is negative 2 over 3, negative 2 over 3, nice. 2x cubed minus 3 over 2x squared plus c, same thing, good. 19 over 2, 19 over 2. 40 and 40. And then 200, but I got 400. I don't know why I did. Oh, I multiplied the wrong thing together. I multiplied n by 10. And I even told you guys, oh man, I wasn't paying attention. You're supposed to multiply the mean. The mean was 20, so this should be 200. Oh well. Okay. I think I only lose 1 mark for it though, so that's not bad. And then variation is 900, 900. Okay, R is 4 centimeters, yep. Okay, I did the drawing right there in red, so that's good. And then A is negative 2, B is negative 1, so that's good right there. Okay, this one I know it's right because it's like an explained question, which I did. Okay, part A, show that D is log CQ, so yep. And then 610, 610, so that's good. Okay, fill out this table, 1/8, 7/8, 1/4, so same thing. Okay, 3 over 32, 3 over 32. Oh, uh-oh, I totally messed this one up. So I should get 8 over 32, and I have 23 over 32. So let's see where I messed up. Oh, I said 1 times 5 was 20. That's my bad. This should be 5. Ah well, let's redo this question because I have the time for it. So this should have been 5. Or not 5, 8. Because 3 plus 5 is 8. Which means that this should be 8. And this one should be 8. Both of these should be 8. And this one should be 8. Okay. Man, how was I not paying attention to that? Okay, this should be easier to do. Maybe that's why it didn't make sense for me to multiply all of those other numbers out. What's 9 times 8? 72? What's 72 times 2? 144? So 208, I guess, should be the proper way to do it. Oh, no, it's not. Because the probability of him not being late is going to be 24. Okay, 24 times 8 is very similar to 25 times 8. So 8 quarters is $2, so that's 200. But then you got a minus 8 cents because it's 24, not 25 times 8, which is 192. So this should be 192. So 4, 8, 3. Does uniformly Cauchy imply uniformly for convergence? Kinda embarrassed, can't remember. I feel like it does. I feel like it does. But I wouldn't trust my word on it. Aren't I taking real analysis? Not really. I mean, we talked about uniformly for convergence, and we talked about Cauchy. I don't remember talking about uniformly Cauchy, or the implication of it, but I'm gonna assume that it does. Okay, does this look more right? I think this is more appropriate. And then again, you can do the same thing this way. Of course, that should be 24 squared. And you should get the same answer. So let's just double check that that is correct now. So 3 over 8, yep. And then they have 7 over 16. So 7 over 16 is this decimal. And then 448 over 1024. Same decimal. Okay, so it's right. Ugh, geez. Okay. Showed this, showed that, so this is all showing stuff. The radius is 2, which leads to 240 pi. So right there, 240 pi. And then last one. So tangent gradient of 3, which is 3 right here. F of 2 is 7, which is right here. Blah 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 chain rule. G prime of 1 should be 6. Oh yeah, that was a showing question, so I showed it. And then blah 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 blah. Y value is 1. Okay, so let's see how badly I screwed up. I lost the mark up above earlier, and then all of this is more or less wrong, I think. So let's see how that would have happened then. So I would get this one right. And I would get this one right. I get this mark, but then I get the answers wrong, so I've lost 2 marks right here. But then all of these I would get right because I got followed through. So I only lost 3 marks out of however many this is out of. $90 marks. So 87 out of 90, which is definitely an IB grade of 7. Nice. Okay, folks. It is a slow Sunday, like I said, and I don't see a point in me continuing to stream. Plus, I'm quite tired from all this packing and cleaning of my house. But for those that are watching, this coming Thursday and Sunday, I'm just focusing on IB trigonometry because my students have a test on IB trigonometry after first day back after their break. Well, actually, I don't know if it's going to be the first day, but I promised that I would be reviewing this big 90-page package of review that I gave them. So if you want to go through some very repetitive trigonometry questions, tune in next time. Otherwise, yeah, I'll see you guys later. Have a good week. Bye-bye.